questions or you want to make a comment, just tell me anytime, interrupt at any time. It's a big class, so I guess like you might be a little bit, I don't know, hesitant, let's say, to ask questions in front of a class. That's fine, because I have psychic powers, which I will practice in this class, because I enjoy practicing and developing my beginner level psychic powers. And sometimes I will take a mind reading, a collective mind reading, and answer your questions even when you haven't asked them. Right? Sometimes, though, I will ask, I will pick on specific people to answer questions. Because I actually enjoy hearing from you. And I enjoy getting feedback and things like that. So let's talk about data visualization. We're going to start off with a psychic reading already. So this is like a collective psychic reading already. I'm going to read your minds. Right? But I'm not only reading your minds, I am reading the minds of many millions of people all across the, let's say, civilized world, at least the world with internet access. This is a ubiquitous pattern of knowledge evolution. So that means it's a pattern, a ubiquitous pattern, or a prevalent of thoughts, a thought pattern that's occurring in everybody's head right now. Right? Not just your head, but everybody's head. Not everybody knows that this pattern, and not everybody has identified exactly this pattern. But once you hear about the pattern, you're like, oh wow, Bob was right. Like, I don't understand how he knew that, but he's right. So it's like drawn as a nice diagram. And it has 6 pieces. And it starts from the beginning in the top left, and then it ends in the bottom right. And the pattern is like this. It starts with a real-world problem, or a challenge, or a goal. Right? We all have problems, or challenges, or goals that we're trying to achieve. Right? You're all trying to pass this module, get a degree. But that also translates into obtain understanding, increase your understanding of some subject. But some sort of layman's examples could be something like building a house. Right? Imagine you want to build your own house. Does anybody here build their own house? That would be shocking. So the pattern of knowledge starts with a goal, a challenge, or some problem, right? And we know that for all of our problems and challenges and goals, there is a physical solution. Right? The physical solution for your university degree problem is that you attend university, go to lectures, do the courseworks, and pay the money, right? For building a house, you know that you could build a house, right? You could do it. You know it's possible, that it's possible. How do you know it's possible that you could build a house? A real house. That's right, people build them, yeah, you've seen, and you live in one, right? You might live in one. So it is possible. You know that there's a physical solution. This is like the real world, by the way. This side is the real world. Real world, challenge, real solution, like a physical solution, like building a house, getting out a hammer and nails and starting to build. But if I asked you to build your own house, like what would you know it's possible, but you might also be hesitating. Why would you hesitate to build your own house? It's not free to build your own house, right? You need to understand, well, you want to understand how to do it, And it's going to cost a lot. It's going to cost a lot in terms of money and your time. In other words, it's not generally feasible to build your own house. You generally pay somebody else to do it. You know you want to build a house and you want to live in a house, you know that there's a physical solution, but oftentimes the real world solution or the physical solution is not feasible. It's either too expensive, it takes too much time, maybe. Sometimes it is impossible, right? For some people it really is impossible to build their own house, right? If they live like underwater or something, then they can't build their own house, right? Because the material, well, anyways, it's not a very good example. So that's the first 3 stages of the knowledge, pattern of knowledge. And you're all with me so far, right? You all understand those 3 stages, and you know, you're familiar with them. Then there's a dashed line separating these 2 halves. This is the real world, and this is the digital world. So because we cannot always solve our problems in the real world because of costs and money and feasibility challenges, we often turn to digital solutions. We think, oh, well, I can't build my own house in the real world, but I can build it in a program. I can build my own house in software. People do that every day, right? People do that as a living. They sit down at a desk with a special piece of software, computer-aided design, and they build houses in software. Right? I watched a guy do it just on Saturday. He sat down and he built a digital conservatory in like 10 minutes, 15 minutes, which is cheaper and faster than building a real conservatory. And it's the same thing with houses. It's the same thing with a lot of like challenges and understandings that we're trying to obtain. That's a very common thought. People generally think, I can't do that in the real world, but I'm sure that there's a software solution to this challenge or this problem or this goal. Very, very common, right? Everybody thinks, oh, there must be an app for that. Like, I need a taxi, but, oh, there must be an app that can get me a taxi, right? That's another example. If you wanted to get a taxi in the real world, you could physically run around everywhere, like everywhere, and knock on the windows of taxi cabs and say, can I, like, ride taxi with you? But you wouldn't do that. You get out your phone and you look for a digital solution, right? I need a taxi. Now we're getting into the fun parts of the ubiquitous pattern of knowledge evolution. Because everybody's following this pattern. This is actually why you're here. This is why you're in this room. And this is why you're all studying computer science. Because you want to be the experts that provide the digital solutions. You want to be the heroes, which is good, by the way. It's good to want to be a hero. But there's a catch. It's not free. Because we're generating digital solutions to all of our challenges and goals, there's a consequence to that, and that is what I call data chaos. All those programs and those pieces of software that exist already and that you guys are going to be working on in the future, maybe already, generate data. And they don't just generate data, they generate massive amounts of endless data, actually. And it's so much that it leads to something called data chaos, which we're going to talk about more as the module goes on. But data chaos is a chaotic state of data. It's very large data, In fact, it's endless. It's very chaotic. Like we don't know where we're storing our data. We don't know who has access to it. We don't know how many copies there are. Right? Just studying at the university, you can sort of see the data chaos with like trying to find a document. Anybody like have trouble finding a document at the university? Data chaos. And the purpose of this module is a response to the data chaos. To get us out of the data chaos, to make sense of the world of data, we need data visualization. This is the response to data chaos. It's the solution to data chaos. Because as soon as we can see the data, the level of chaos is controllable. It's reduced. Right? We have it under control as soon as we can see it. Right? And that's what data visualization is all about. Making pictures of data. Is that exciting? It's going to get more and more exciting as we go along, by the way. Any questions about that? Did everybody follow that? I know what some of you are thinking. You're like, how did Bob do such a collective psychic reading? Like, how did he know that about me? And society. Nobody really understands how psychic powers work fully, right? They just, thoughts come in some people's heads, and then they go into other people's heads, and nobody fully understands how, right? Here are some examples of this people generating data and common sources of data. On the left side are people that are generating data as part of their job, like professionally. And then on the right side it gets a little bit more personal on an individual basis-ish. Like you guys, for example. Anybody here ever try to study engineering or been exposed to a level of engineering or have any friends in engineering? Nice, nice. So the Swansea University has a very large engineering department, right? And a lot of them are generating gigabytes and petabytes of simulation data. Right? I'm not going to go into it in detail. I'll ask you to trust me on that one. Just ask your friends in engineering if they've ever heard of computational fluid dynamics, which we are going to talk about, by the way, later on in the module. We're not going to talk about it in detail, but you'll know what that is by the time you finish this module. Physicists and astronomers. Anybody have any friends in physics? Those bold people, those brainiacs. Physics and astronomers collect endless amounts of data through experiments and imagery. Right? They're always taking pictures of different celestial phenomena, right? And they're endless sources of data. Right? They're just endless. Marine biologists and bioscientists. Anybody here made friends with the bioscientists? Any bioscientists at Swansea? I see one. Same people making friends with the other departments. That's going to bring you good luck, by the way. So, we have a very active bioscience and marine biology at Swansea, and they go out into the real world and they attach little sensor devices to actual animals, like turtles, and penguins, and cormorants, and birds. They attach the sensor device, let the animal go for a few hours or a few days, collect the device back, and then try to figure out what the animal did while it was wearing that sensor. Right? It's gigabytes and gigabytes of data. Psychologists and sociologists and criminologists, they love to give out surveys, right? Collect surveys about data. I actually had somebody from the business school asked me if I could help them visualize their survey data. I said, maybe. How many surveys do you have? And she said, 8,000. I said, okay. Are they, I had to ask. I said, are they in paper format or digital format? And the answer is clear, they were in paper format. So there's not that much I could do actually. Anyways. We have sports scientists, we have a sports science group, right? Everybody loves sports, rugby, everybody loves rugby. I'm sure everybody here watched the Super Bowl. Sports scientists have a lot of data. Anybody know what that data looks like? What sports data looks like? You actually already know what it looks like because you've seen it. You just maybe never got that question before. It looks like a video. It's a video, right? A game being played. That's data. Right? Video data. We know that there's lots of data in the humanities. Right? You walk into a library. Anybody here visit the library here? That's data. Every single letter stored in the library is data. That's serious, serious data. And that's a small library, by the way. There are much bigger libraries than that library here. Right, the governments and councils are collecting data, right, whether or not you paid your council tax, how much council tax you paid. Right, they're keeping very careful track of trying to figure out how to manage the city's resources. Those are just a few examples, right, on the sort of the professional world. And then if we go towards the sort of the individual world, like your world, for example, right, every time you go to the bank, like every transaction you make is recorded for your entire life, right? And you're on CCTV as well. Every time you go to the ATM, right, you have a camera pointing at you. Lots and lots of data. Banks have a lot of data, right? Just every time you check your statements, they're going to log that information. Every time you make a phone call, that data is collected and stored, right? Everybody know that? Every phone call you make is stored in a database. Every time you push a button and connect, that data is stored. Every time you go shopping, right, somebody's collecting data about your shopping habits, trying to get your money, get you to buy more things. Right? Tesco is putting, like, I don't know, they're putting like the bread at one corner of the store and then the butter at the other corner. Everybody know about that? So you have to see all the other products before you get your bread and butter. Hopefully it's vegan butter. So you get the idea, right? Lots of examples. Every time you look at a web page, that data is recorded by a number of different people. Every time you get on transport, that data is recorded. Now, there's an initiative called Smart City Data, right, that's trying to take that data and make a city more efficient, more knowledgeable. There's healthcare data. Every time you visit the doctor, that data is recorded. And that is assignment 1, by the way. Assignment 1 is to figure this out. It's very exciting. Really, really excited. And then you have like data that you're collecting, right? You are collecting data. You're collecting your own photos and videos and files on your laptop. You're collecting selfies, right? So you can have the biggest collection of selfies, right? It's really, that's data. It's everywhere, everyone. And partially, it's just because people like to collect. People just like to collect. Does anybody here collect anything besides selfies? I do, actually. I think a lot of people here collect things besides selfies. The attendance register, Roger, do you collect anything besides selfies? Books, exactly. Another psychic moment. I collect books, and I like to collect audio books. Not all of them, but just like the ones I think are interesting. Any questions so far? Everybody get the idea? Like, this is the motivation behind this module and this field of study. It's the data chaos. It's everywhere. And now you'll be able to see it everywhere. Right? You'll notice it. Probably a lot of you noticed it already. Right? Okay, so why should we care about data visualization? I mean, besides the fact that the world is creating endless amounts of data, we may as well use our visual system to try to understand it. We may as well take advantage of it, right? Because the visual system is our most powerful sensory system by far. So we may as well use it, right? We have several billion neurons devoted just to the visual, to processing and analyzing visual information, about 30% of our cortex. And that's interesting, but it's even more interesting when we compare it to our other senses, like how much of our cortex is used for hearing and it's touch. Only 8% of our cortex is approximately used for touch, kinesthetic information, and only 3% for hearing. So if we're going to try to bring in information into our heads, it may as well be through our eyes, right? Because it's a very high throughput. A little bit of background on the field, so to speak. It's kind of a young field. It's kind of immature, as you can probably tell by looking at me. It's okay, manual visualization is very old. By manual, we mean like hand-drawn. So you can find examples of hieroglyphs and cave drawings, right? Those are manual, hand-drawn visualizations. But we're not talking about manual visualization in this module. We're talking about what you could call computer-assisted visualization, or computer-aided visualization. And as a field, it's generally, there's a sort of loose consensus that it started in 1987. So not very long ago, if you compare it to some of the other fields like artificial intelligence and mathematics and stuff like that. It's quite young. There are younger fields, but it's fairly young. And the first conference was in 1990.
What marks 1987?
What happened in 1987? That's an interest. Nobody's ever asked that question before, actually. Somebody published a report in the United States asking for money from the National Science Foundation, saying, we need money for data visualization, like just for data visualization. So that was the first time somebody wrote a report and asked for money just for data visualization. Before that, it was buried, or it was combined with computer graphics. It was sort of mixed in with the computer graphics stuff. And the UK is still playing catch up, by the way. The UK is still like trying to catch up to some of the other countries that are more advanced in this discipline than the UK, as shocking as that may be. So that's what happened. And then the first book came out in 1997. That now we're getting really young, I would say. Like that's kind of the first book. Okay, that's pretty recent actually for the very first book. Look, here are some very old hand-drawn info-viz diagrams, by the way. This is just some examples, right? I think you've all been to the hospital, right? And you've had things like x-rays, maybe. Anybody here have an x-ray before? And maybe even a more advanced MRI scan or a CT scan, right? Those are more expensive. But this is an example of from medicine. Anybody know what those surfaces are called? Those are special kinds of surfaces. Anybody already know what those are called? Is the attendance register still being passed around, or is it finished? It's finished? I love it when it's finished. Those are called, I know, I'm not going to pick on anybody because that's an advanced question. Those are called isosurfaces. And we're going to look at what isosurfaces are in this module and how to create them. Here's another example of some vector field visualization or flow visualization. Anybody want to hazard a guess what that is, this thing here? Look familiar to anybody? Times are changing. Are there any motor heads in the module? Anybody here drive a car? I think some people here drive cars, right? It's a piece of your car. It's a little hint. Anybody want to? This is the same thing, by the way. This is the top view, and this is the side view. The gear? The gear has a name in the car, right? It's not called the gear, it's like the crankshaft, right? That's what the gear is in the car. I'm not a motorhead. I hate cars. I hate cars. But I did work for, this is a software version of a car, right? Cars are built in software before they're built in hardware. So they're built in the digital world before they're built in the physical world. Anybody know about the Bloodhound project? So that Swansea University is part of that, right? And the engineering department is actually building digital versions of Bloodhound before the physical ones get built. So this is a combustion chamber. Right? This is inside this chamber is where the fuel explodes. And these are intake and outtake ports, so fuel injection and then exhaust. There's not going to be a test about automechanical. Well, maybe we should. There's not going to be a test about automobile parts, but I don't know. It's kind of interesting. I mean, has anybody here looked at an engine before? Like actually looked at it? It's interesting to know how things work a little bit, right? A little bit. These are some examples from the world of information visualization. And this is abstract data, so the data has no inherent geometry. Like the other ones, there was an inherent geometry. And we were trying to see natural phenomena, like parts of the human body, or the way fluid flows. But here, we don't have the geometry associated with the data. And so we have abstract depictions of the data. This happens to be the example from marine biology that I mentioned with the sensor devices. So this is somebody trying to visualize the sensor data from one of those sensors that are attached to an animal. This is actually somebody trying to understand car automotive warranty data. So every piece of your car has a certain warranty associated with it. And this is somebody trying to make heads or tails of that. And this is also the biology. It also occurred to me that I didn't really say what data visualization is. I sort of said it, but I'll just mention it in a little bit more detail. So data visualization is using computer graphics to generate pictures of data. That's what we're here. That's what we're here to learn. And there's another way I like to think of it. Has anybody here, I guess you all took the computer graphics module, right, in the second year? Yeah, I think it's mandatory, yeah? Anybody know the difference between computer graphics and data visualization? This is what I think is okay for me to ask people in the audience, if I can pronounce names. How about Gareth Andrews? Where is Gareth Andrews? What do you think the difference is? Any idea? You took computer graphics, yeah? Anybody want to help Gareth? He's got like the spotlight of...
It's visualization using like real world data for graphics can generate it.
Well done, well done. So lots of pressure, like well done. The guy that can perform under pressure right there. So the difference, when you hear the phrase computer graphics, you think of amazing things, right? Like Lord of the Rings, Star Wars, Toy Story. You think of movies and one other thing, games. I think of Nintendo. But that's what you associate with computer graphics generally. Data visual, that's fiction. So games and movies are fiction. In case you didn't know, movies are fiction. Data visualization is like the non-fiction version of computer graphics. So it's trying to depict reality. It's using graphics, but trying to depict reality. So those images, hopefully, are real things that you see. They're not always real things, but the goal is to make something that depicts reality, or non-fiction. It's like the non-fiction version of computer graphics. That's how I explain that to my mom, for example, whenever she asks, which she does every day. Okay, so what are the goals of visualization? I am conscious of the time, so we're not going to go on forever. The goals are, this is a very important slide, by the way. Sometimes it's featured on a test. The goals are to explore data, or to facilitate or enable data exploration. That is when you don't know what your data is, you don't really understand it. You're trying to figure out what it is, if there are any outliers, trends, or patterns. And that's going to be, by the way, that's going to be assignment 1. You're going to be exploring the NHS data. Has anybody already done that, by the way? That would be shocking. You have already? How did you do that? Like, as part of your third-year project? Excuse me?
I have a degree, so it works on a lot of things. From England, like public health England.
Why did you do it? Like,
So I have a degree in health.
you already have a degree in health science, so
Yeah.
that's awesome. So you're going to love the first assignment. So yeah, Public Health England releases massive amounts of population health data. Massive. And our job, we are going to solve all of their problems by exploring and presenting it using database. It's public data, public data. This is good for analysis. So that's when you are finished with your exploration. Maybe you're an expert on your data and you collected it yourself, like we mentioned in that slide with all the the data sources. And you know why it was collected and what questions are trying to be answered while it was collected. And you want to confirm or refute a hypothesis. That's called analysis. And then presentation, which is what we're doing now. Once exploration and analysis are finished, and you want to present or communicate the results of those phases to a general audience. Right? The data visualization is very good for that. And then two more subtle good properties of data visualization: acceleration and validation. So accelerate means making something go faster. If you're searching for something, if you have a massive data set and you're searching for something, data visualization is going to make that search process much faster, much faster. In fact, if you don't use data visualization, you may never find what you're looking for. You will often never find what you're searching for if I just give you a big data set. Right? A big data set's not going to be useful until you can see it. And validation is also can be thought of as increasing confidence that what you're doing is correct. As soon as you can see the data that you're working with, you increase your confidence that what you're doing is actually correct. Or what often happens in the real world, you discover that you've made an error or a number of errors, right, and you need to fix them. That's usually what happens actually, as soon as you start. But that's also called validation. Right? So it's good for acceleration and validation. We have three kind of, I'm going to wave my hands for a little bit. We have three kind of subfields. There's a green line here, and above the green line is scientific visualization. So that's data that's centered around something occurring in nature, a natural phenomena. Like people, medicine, fluid flow, and those kinds of things. Something that occurs in nature, a natural phenomena. And it has an inherent geometry. Generally speaking, right? We're studying the form that the world takes. And then below the green line is information visualization, which is abstract data. Data that does not necessarily have an inherent geometry. It's not necessarily a natural phenomenon. Can anybody think of an example that I mentioned already of information visualization? I know it's getting late. So like the survey data, there's no inherent geometry associated with survey data. It's just collected on paper. Right, 8,000 sheets of paper or something like that. The automotive warranty data, there's no geometry associated with that. So we have these three kind of things. We're going to spend some time in the module talking about information visualization, and we're going to go to volume viz, and then flow visualization. So kind of a third each, kind of. And I guess we're thinking about stopping, aren't we? Yes, are there any questions? Everybody really excited about this module? It is a very exciting module. Okay, we're going to stop here and continue